Okay, we're going to look at some of the basic linear information. So we start with a revision of straight lines. Alright, so we're looking at the linear equation. First equation we're going to look at is the gradient slash y-intercept form. Now this is y equals mx plus c. So remember, m, that value there is standing for the size of our gradient, and the plus c at the end there was our y-intercept, and that's always when x is equal to 0. Okay, so let's look at an example. Some of the types of questions we get is something like this. Determine the gradient and y-intercept from the following equations. Okay, given the first equation, y equals 2x plus 3. Our gradient there is the value in front of x, which is 2. And our y-intercept there is the constant by itself, or the number by itself, which is 3. Let's look at another example. Y equals x over 4, subtract away 1. Right, our gradient there, bit harder, we have a 1 in front of our x, and the 4 is associated with the x as well. So 1 over 4 is our gradient, or 1/4. Now our y-intercept is the minus 1 at the end there. So we need to include that minus with it. Okay, another example. Y is equal to negative 3x over 5, subtract away a half. So our gradient there again, it's the value in front of the x, which is negative 3 over 5. And our y-intercept is negative a half, our constant there at the end, or number by itself. All right, a final example here. Y is equal to 4, subtract away 2x. This is commonly done incorrectly, but our gradient there is in fact negative 2. So the negative is attached with the 2 there. And our y-intercept is the constant, or the number left by itself, which is 4. Right, let's look at the gradient of a straight line. Gradient is the slope or steepness of a line. The value of the gradient tells us two aspects of the line. Number one, it tells us how steep the line is. And number two, it simply tells us the direction of the line. So let's look at an example. Negative 3. All right, the 3 part tells us that it has a size of 3. We can look at that as a fraction, as 3 over 1. The negative part tells us the direction of the line. So sometimes gradient can be referred to as rate of change, or simply the change in y over the change in x. Let's look at some examples of gradient. We have the positive gradient, we have negative gradients, so look at the direction of those ones. We have a zero gradient, which means we have a horizontal line, and we have an infinite gradient, which is an extremely large, or the largest number we could have, and it's vertical. Clearly that's not vertical, but hey, we're not all perfect. Calculating gradients. To find the gradient of any line, we need 2 points that lie on the line. Alright, so from a graph, let's look at our graph here with our x and y axes. Let's draw a nice straight line there. Let's look at 2 points there. Right, so to determine the gradient from those 2 points, we use the concept of rise over run. So we did this in year 10. So let's look at our coordinates there being 3, 1, and 5, and 5. Our rise over run, our rise part is how much it goes up by, or down. So that goes from 1 through to 5, so it goes up 4, and it's going across by 3 to 5, so our x value is there, which is 2, so 4 over 2. So we look at the rise and how much it runs across. And there's our way of finding our gradient from a graph. All right, now let's say we don't have a graph. We're going to look at the gradient by using a formula. So remember, gradient is change in y over change in x, so we look at that as being y2 minus y1 over x2 minus x1. So we use that to help us. Here we go. Our 2 points, 3 and 1, 5 and 5, as above in the graph. Label the first one x1, y1, second one's x2, y2. Now let's substitute in y2 is 5, y1 is 1. So we're going to have 5, subtract away 1, over x2 is 5, x1 is 3, so 5 take 3. That equals 4 over 2, which equals 2. So it confirms that the gradients are the same, as the points we're using are the same. Determine the y-intercept. So from a graph, although this is straightforward, I'll point out some obvious points here. We have our xy axis, a straight line, and the y-intercept is simply where the line cuts the y-axis. All right, so this is where the line cuts the y-axis. And it's important to note that the value of the x at this point is always equal to 0. So to find the y-intercept, we substitute x equals 0 into our equation, if we've been given one. So let's look at an example. Find the y-intercept for, here we go, y equals 2x plus 5. All right, now we'll substitute x equals 0 into there to get y equals 2 times 0 plus 5. That leaves us with just 5. So our y-intercept there is 5. Now that's already in gradient y-intercept form, so we don't need to do that, but that just confirms that it works. Let's look at this equation. 3x plus 2y is equal to 4. Let's substitute x equals 0 into this equation. We're going to have 3 multiplied by 0, which is 0, plus 2y equals 4. That equals 2 equals 4. Divide both sides by 2. We get y is equal to 2, and that's our y-intercept there at y equals 2. All right, let's look at an example where we can use this. So, if we have the gradient of a line equaling to 2, and the line passes through the point 4, 6, we're usually asked to maybe determine the equation of the line. So, what do we need to determine the equation of the line? We need to know the gradient, and we need to know the y-intercept. All right, so look back up the question. We've got the gradient, that's equal to 2. So we know that the m value there is 2. So let's write down our equation now, y equals 2x plus c. Now what we need to do is we need to find the c value. So let's look at the point that it passes through. So we've got 4/6. Right, now we substitute our x and y value in. So we put the 6 in place of the y there. And we replace the x with the 4. So that becomes 2 times 4 plus c. We solve now for c. That means we take 8 from both sides there to remove the 8. 6 take 8 is -2, and we get c equaling -2. Now we haven't found our equation yet, we've just simply found our c or our y-intercept. So let's rewrite that out. Therefore, our equation will be y equals 2x, and that's take 2 because our y-intercept is -2. All right, let's look at a second example here. So remember, it's important to read the questions so we understand what we're looking for. So we've been given y equals 3x plus c. We've been given a point -1, 4 that passes through that line, and we're asked to find c. So remember, we don't need to find the equation here. We're just after finding the c value or the y-intercept. Substitute the points in. We get 4 is equal to -3 plus c. Get rid of that -3, and we get c is equal to 7. So we've found our answer there. Okay, how does this help us? So I suppose to find the y-intercept, we need to, I suppose, be given the gradient and then also have a point that lies on that line. That enables us to find the y-intercept, which also enables us to find the equation of a line. So in order to find the equation of any line, all we really need is 2 points. Okay, once we have 2 points, we only need those 2 points, we can find the gradient and then we can find the y-intercept. So let's look at an example. Determine the equation of the line that passes through the points. And there they are, 2 and 5, and 4 and 9. So we've got 2 and 5 and 4 and 9. So number 1, we need to find the gradient first. Okay, so let's label our points as x1 and y1. And then x2 and y2. So there's our first coordinate, and there's our second coordinate. Now let's use our formula, y2 take y1, so 9 take 5, and x2 take x1. We get 4/2, and we get our gradient equaling to 2. So let's put that into our equation, so we get y equals 2x plus c. Let's look at substituting one of those points in to find our c value now. So let's choose 2 and 5. It's a smaller number, it makes things easier. So 5 is equal to 2 times 2 plus c. 5 equals 4 plus c, and we get c equaling to 1. And now we finish our equation off by putting that 1 value in, so we get y equals 2x plus 1. And that's our equation of our line that passes through those 2 points. Let's look at another example here. We'll make this one a little bit more difficult by putting some negative values in there. All right, -4, -2, and then let's look at 2 and maybe 10. All right, label them x1, y1, x2, y2. There's our 2 points. And again, one, we need to find the gradient. So we need that gradient. So let's use our formula, y2 minus y1. So 10 subtract away -2. So 10 subtract away -2. Now this is a difficult one because sometimes we forget to put the negative with the 2 as well. So notice it's got 10 take -2. Now let's do the same at the bottom. 2 subtract away -4. And 2 negatives there, subtracting away a negative becomes a positive. So we get 12 over 6, which equals 2. So therefore our gradient is 2 and our equation is y equals 2x plus c. Choose a point to substitute in. I'm going to choose 2 and 10. They're positive numbers. Maybe it's a bit easier using positive numbers. So y equals 10, x equals 2, and I get 10 is equaling to 4 plus c. C therefore equals 6. So we take 4 from both sides. We get c equals 6. Now final equation there is y equals 2x plus 6.